Keith Raymond's talk on automated hauler development will start at 10:45 a.m. Until then, Glen Murphy will give a talk on in-forest debarking. Hi, my name is Glen Murphy. This morning I am going to give you a presentation on in-forest debarking. This work has been funded by the Forest Growers Levy Trust, the forest industry, and the Ministry for Primary Industries. In 2012, Spaniard and Warburton undertook a review of opportunities for and barriers against innovation in 3 New Zealand export industries: forestry, meat, and wine. They identified 7 areas for improving innovation and competitiveness. One of these was supply chain restructuring. The in-forest debarking project is about restructuring the forestry supply chain by moving the debarking process from near the end of the supply chain to near the beginning. So why is this important? Bark is a low-value product that adds cost from forest to customer. About 1 million tonnes of bark gets a free ride each year. If we can get rid of bark early in the supply chain, we can drive down costs. For example, if a load of logs fully clothed in bark is transported to a customer, about 8% of the weight is bark, about 50% is water, and about 42% is solid wood. If we eliminate the bark, we can also reduce the amount of water in the logs through in-forest drying and increase the amount of solid wood trucked to the customer. Making a change to any supply chain isn't simple. There are disadvantages as well as advantages to in-forest debarking. Disadvantages may include the cost of debarking in the forest, loss of income if wood is sold on a weight rather than volume basis, increased handling and transport costs for slippery logs, possible increases in site preparation costs, increases in landing size, potential value losses due to sap stain, and reduced revenues from bark sales. On the advantages side, there are reduced trucking and shipping transport costs, improved storage at mills and ports, reduced need for fumigation, the potential to eliminate weight scaling, reduced bark contaminants at ports, reduced need for shipping to visit multiple ports, collection, transport, and disposal of bark is eliminated, and improved log dimension and quality measurement accuracy. Before we look at purposefully removing the bark in the forest, let's remind ourselves of how much bark is removed through other activities. This photo was taken at the port of Tauranga. The great majority of the bark is still present on these logs. These logs were processed with a motor manual system. This next photo was also taken at the port of Tauranga and on the same day as the first photo. There is very little bark left on these logs. These logs were processed with a mechanised harvesting system. Studies that were carried out 4 or 5 years ago in radiata pine stands found that the amount of bark remaining was greater with manual processing than mechanised processing, in winter than in spring, with cut-to-length systems than in tree-length systems, and with less handling of logs. On average though, at least 20% of the bark is still on the logs after the stems have been felled, extracted to the landing, and processed into logs. So the next question is, how much bark is there on a stem to start with? On a standing tree, bark makes up 12 to 13% of the overbark stem volume, It varies with height in the stem, with tree size, and with location in New Zealand. It accounts for 7 to 8% of the overbark stem weight. Debarking of logs remains an essential task within the value chain of all timber processing industries. Wood needs to be debarked before it can be processed into further products. When it comes to debarking of logs, what is an acceptable standard? Well, pulping processors prefer 2% or less in the chips they receive. Let's look for a moment at our supply chain and other debarking requirements within the chain. About 40% of our volume goes to domestic customers. Pulp logs have to be debarked to 2% or less by volume to meet the standards. The requirement for domestic saw logs is even tougher. Since it is mostly the outside of a saw log that is converted to chip and sent to a pulp mill, the standard is tougher. Less than 1% of bark should remain on the log after debarking. About 60% of the harvest volume is exported, and 80% of that is sent to China. China will accept debarking as an alternative to methyl bromide treatment. The standard is that no more than 2% of the volume of a group of logs can be bark, and no more than 5% on an individual log. In-forest debarking is one of the projects included within the new Automated Forestry Value Chain Primary Growth Partnership Program. The objective of the project is to develop a low-cost process for debarking logs early in the value chain that meet the required quality standards. The project has been underway for almost 12 months. Waratah and 141 are participating in the project. So what progress have we made? A literature review of promising debarking concepts has been completed. We found that there were many technologies that could be used for debarking. We found that it is unlikely that current processor heads could achieve the debarking standards in an economical manner. And we found that a computer vision plus artificial intelligence system might be able to help determine when the standard has been reached with minimal fibre loss. A concept generation exercise has also been completed. Alternative concepts for one machine and two machine systems have been identified, and the advantages and disadvantages of each concept discussed in detail by the forest owner representatives and the machinery manufacturer's engineering staff. We have developed a structured process for selecting the most promising concept. This process has included determining the selection criteria and attaching importance weightings to them, then making pairwise comparisons of concepts for each criterion, and finally combining the weights and comparison scores to arrive at the best overall concept score. 7 criteria have been chosen for the selection process. These include market potential, debarker operational issues, debarker reliability and durability, system productivity impacts, machine and harvesting costs, overall system costs, and human factors. We have also completed machine, harvesting, and system cost comparisons for each of the concepts based on the best information available. And of course, carried out sensitivity analyses, since for these new machine concepts, we have had to make educated estimates of likely capital costs and productivity rates. The final progress that we have made relates to the computer vision component of the design. Requests for proposals for a bark recognition and sizing system have been sent out. At the same time, we also requested proposals for a knot recognition and sizing system for logs that have been debarked. 3 organisations have indicated that they will be submitting proposals for both systems by the end of this month. The near-term next steps for this project are to finalise the concept evaluation and selection, to review the computer vision RFPs, to carry out system-level economic feasibility analyses. This will be a stop-go point for the project. If the concepts do not look to be economically viable, the project will stop at that point. If it is economically viable, then we will agree on the operating parameters and the design specifications that will be needed to build an alpha prototype of an in-forest debarking machine in 2021. Thank you for watching this presentation on in-forest debarking of radiata pine to improve supply chain efficiency.